let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so
we
awesome.
are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Expert Office Hours live stream. I am co-host Andrew Sullivan, and I am, sadly for me, but very fortunately for him, not joined by my co-host Jonny Rickard today. Jonny is on some very well-deserved, very earned PTO for the last week or so, and I'm looking forward to having him back. I miss him, but I'm very happy that he gets to relax and get away for a little bit and not worry about work, although he still keeps messaging me about things. So.
Oh no, shut off his Slack.
Yeah, well, it's funny. So I'm actually going to be on PTO next week, and so I'm a manager, right? I have a team of folks, and in Slack, when I'm on PTO, I mute everything except my team is VIP, so they can still reach me if they need to, right? Because things like emergencies come up sometimes, and I accept that in my role as a manager that I have responsibilities, and that's just how it is.
Yeah, see, I'm an individual contributor, so I delete the Slack app and then go on vacation.
Yeah,
it's,
see, and
that time's fabulous, but
that's the smart thing. A few years ago, probably 4 or 5 years ago now, I switched over. I'm looking at my phone, like y'all can tell what I'm looking at. I switched over from Android to iPhone, and I missed the work profile in Android because I could, it's one toggle to turn off the work profile, and then none of the work things would interrupt me, or I even had to know or care about them for whatever length of time that was, which was really nice.
It's a nice feature.
So anyways, so we missed Jonny. Jonny will be back next week, but this week we have the Portworx folks coming back on. I say folks, it's Chris, coming on to talk about a few things this week. So the last time I remember, and I'm pretty sure that y'all haven't been back on since then, was last November when we had Ryan on, and he was talking to us about a few things with Portworx. He hinted at a thing called KDS, which I think we're going to talk about.
Yep.
So I'm excited, and I'm very interested to hear all the things that y'all have to say. And behind the scenes, Chris, you know that we've been working on a few things jointly as well. So I'm happy to share and talk about some of those things as well. So Chris, I'll let you introduce yourself real quick, and then I'll do a quick top of mind type of thing, and then we'll launch into the topic.
Sounds good. Yeah, so Chris Crow, I am a peer of Ryan Wallner, who was going to be on today, but through was coming off vacation and was playing some planes, trains, and automobiles to get home, which was a wild story. Won't bore people with it here, but he might be a little tired after what ended up being like a 16-hour straight shot drive with a 2.5-year-old. But so I work in the Portworx technical marketing department. I've actually been around Pure since 2020, started in the SE space, was a cloud native architect for a period there, and then eventually found my home in the technical marketing department because it feels like less travel and a lot more time in labs, and I love labs. So I spend my time building learning labs, playing with things, breaking things, fixing things, and probably breaking things again. I just hope the balance of fixing to breaking is, in my favor.
But you can't learn about it if you don't break it. that was
too many loose ends, and then I never learn anything. It's the fixing after I break it, I feel like, but I digress.
Well, I fully sympathize and empathize with all of that. I enjoy the breaking aspect as well. We were chatting beforehand of I normally before the stream I do some research and figure out like what I'm going to talk about on top of mind. And I didn't have time this morning because I was busy arguing with the LLM that I have. So I deployed the OpenShift MCP server, which is in Tech Preview, because I was like, oh, I start using it. I want to check it out. I want to experiment with this thing. So we had Claude Code, and I've had a cluster. It's a 422 cluster deployed for a couple of weeks now, and my console keeps logging me out. And it was one of those like, okay, what's going on here? And couldn't figure it out. I was looking at the session log, timeouts and stuff like that, changed those values, kept logging me out. So finally I'm like, oh, MCP, I'll use technology to help me. And so it goes through and identifies that, oh, well, your console pods are, the deployment just constantly rolls out. It's been through like 7,000 rollouts in the last 7 days. Like, okay. And then it's like, well, it's because of the ODF console. Well, great. Well, what's wrong with the ODF console? Well, it keeps changing its configuration. Well, what's changing? Well, nothing's changing. Then why is it like, so I end up in this, argument loop with it of like, well, did you look at the logs? Yes, the logs say blah, blah, blah. And it says that this object changed. Well, what changed about it? Well, nothing changed about it. But you just said something changed about it. Anyways, long story short, I fixed it by upgrading ODF to 422. And, it was ODF 421 in my lab cluster. And I updated it.
That was doing it, huh?
And that was what was doing it.
Do you wonder if this is a little bit of what our future is going to look like, that feels like arguing with toddlers about the technology? Because the interfaces, I mean, you think about it, we have computers that they think in binary. We have languages that get progressively easier for us as it moves, closer to natural language, from C to C++, all the way to Python and these high level languages. And almost like so then we teach a computer how to at least mathematically, I'll say, understand text. So we can teach it how to use natural language for programming, and then we take yet one more step back to interface with this now. And I have it happen all the time. I had a PeerTube instance fail yesterday. Turned out it was my mail server was sending an OAuth header back to the mail client of PeerTube, and it was actually crashing because of it. What struck me about the troubleshooting session is I didn't bother logging into anything, because I was actually out walking the dog. So I with my phone, asked the agent, what's going on?
Yep.
And it gets it, and similar thing, it gets it wrong a couple of times. But it did an admirable job of finding the root cause, and then eventually getting to the point saying, oh, well, you dummy, you configured the wrong SMTP endpoint, so it was giving you the wrong auth header. There's actually an internal endpoint. Anyone in the audience running Stalwart, it's fantastic mail server, but sometimes frustrating. So, but kind of struck me that my troubleshooting session was actually through a Matrix chat instance. And which was a little wild to me. If you said I would be doing that 5 years ago, I wouldn't have believed you.
I'm with you. And it's funny because it's this weird juxtaposition of sometimes, and I say this with no malice for our future AI overlords, sometimes it's a complete and utter idiot. And sometimes it's brilliant. So it's like going through the session. About halfway through, it suddenly switched from using MCP and like pulling information out to requesting to run OC commands. So finally, I'm like, why are you using OC commands?
Yeah.
Oh, you're right. I should be using MCP. I don't know why I switched to using OC. Like, what just happened here?
Yeah.
So it's funny you say that, because so back at Summit, I had a huge number of customer meetings. We call them the CBC meetings, customer briefing center meetings, and probably 2/3 of them were folks asking about things like MCP and LLM integration, not within OpenShift, because we have Lightspeed within OpenShift. But like, hey, kind of this same scenario that you and I have been describing, which is on my Claude Code instance, or my Claude desktop or whatever, I have this session and I want to use that to interface with my cluster and be able to do things. And how does that change the way that I operate as an administrator, as a developer?
Yeah.
And again, to your point, it's funny because the first time I had that conversation, I'm sitting there thinking of like, when I was an administrator, I'd come in the morning, pour myself a cup of coffee, sit down and open up 10 tabs, 4 of them for various vCenters, 2 of them for various storage systems, another 3 for whatever monitoring systems that are up and looking at applications and all of that. And then you sit down and you look for red and yellow.
Yeah.
And your morning starts off with, okay, well, why is this red? Why is this yellow? And let me trace it back. And now it's one of those of like, I think I would just switch to using something, an LLM that basically does that for me. Hey, go look at my empire and tell me what I need to care about.
And to your point, a certain amount of that feels like providing AI with the tool sets. Like I built a Portworx documentation MCP server for exactly the reasons that you're talking about, because getting these systems that are, I think I have a toddler running around the house, so it feels like an apt comparison that it's almost like talking to a toddler at times. Like,
Yeah.
oh, do you want juice for breakfast? No, I mean yes. No, I mean, but but providing that correct context of same thing. I ingest OpenShift documentation into a memory system, so it has it available, and am starting to get to the point of developing agentic loops to handle what my day-to-day lab building job was, where I used to be doing the direct testing. But after all, if I can have it iterate through loops and build something for me while I'm playing pickleball, sounds like a more ideal future. I'm hoping we go more Star Trek than Blade Runner, but we'll see.
Again, to your point, like the agentic loops thing. I've been a manager for 4 years now, 3.5 years, something like that. And what I realize is the longer I'm a manager, right, the further away from the hands-on keyboard, like deep technical stuff I end up doing.
Yeah.
But I miss that. And so instead, now I spend a lot of my time doing document reviews. Hey, can you look at this blog post? Hey, can you look at this, this other thing, and give us your feedback and stuff like that. I was looking at the Perf and Scale team did a SQL database performance test on OpenShift virtualization, and they hit something like 2.7 million transactions per second before the local storage just capped out, right?
Yeah.
Type of thing. And so I'm looking through this, and it's one of those like, okay, I have a common set of feedback that I make, right? Things like, do you have a call to action? Are you setting up the premise of this blog post, and blah 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 and all that? Then I go, why am I doing this repeatedly? Like, so I was yesterday afternoon, I sat down again. I use Hermes through a Mattermost instance is how I interface with it, and basically said, hey, I want to create an agent that does my initial review for me.
Yeah.
I'm going to give you the link to a document. You go and apply this logic and give me the feedback that I would have normally had to spend my time doing. And I'm hopeful that it's not going to replace me, but it will accelerate my ability to do that, so that instead of having to spend an hour on the first set of feedback, I can now spend 10 minutes or something like that.
Yeah, there's certain things I think it'll be great for, and certain things I think we'll still need. Almost like IT feels closer to school. Like we're doing it for learning, for the discipline of learning, not because necessarily we need it for the output, but we need to get to that point in order to really act as that architect. I think in a lot of ways. But I'll be curious. I'll be curious how this unfolds over the next decade. So,
well,
2.5 months as the rate of things is changing.
2.5, man, that's let's hope it takes that long. It feels like it's gonna happen any minute. No, it's funny. I was talking with one of my marketing counterparts about, like, how do we create an agentic content pipeline? So basically, I can take an idea. So one of the recent ones we worked on was memory efficiency with OpenShift virtualization. So I can take that idea and say, hey, create a blog post on this topic. And then there's an agent that goes in and validates that topic and does research to get supporting information. And then it feeds it into an outline agent that feeds it into a draft agent that feeds it into a review agent.
Oh, wow.
And then you go through this thought process of like, okay, the human comes in at the end and basically reviews this thing and says it's okay. But what if my passion is writing, right? How can I, like, I don't want to replace that part. What's the thing about, like, we want AI to mow the grass and do the dishes for us so we can spend more time on art instead of doing art for us so we have more time for dishes and laundry.
Oh, 100%. It's yeah.
So it's like, how do we fit in there? And then, like, I'm a technical person, so I derive a lot of value, and a huge part of my base of knowledge and experience is doing the research for things like that. I think memory efficiency comes through things like it's KVM, so things like KSM, key same page merging or kernel same page merging, and free page reporting and all these other things, like doing the research to learn about those things and figure out how they work and what it means and what the implications are and testing those things. I don't want to replace that. I want to keep doing that. And if I do replace it, what does it mean for me in the next 1, 3, 5 years as my knowledge base dwindles and becomes outdated? Because well, I'm replacing it with an agent. So I don't know. Anyways, big philosophical questions that I'm realizing we're 15 minutes in here, and
the best way to start.
I'm pontificating about AI. Yeah. Anyways, long story short, so I don't have a lot for today's top of mind, largely because I was arguing with the LLM. So I
fair enough.
For better, for worse. I do have one thing that I want to share, which is we semi-recently published, separate from one of the things that we'll be talking about today, an OpenShift virtualization operations guide. So this is not specific to any integration or anything like that in particular. Rather, it is broadly OpenShift virtualization, and really OpenShift, because OpenShift virtualization is OpenShift. It's about 110 pages of bedtime reading. So if you're having trouble sleeping, I highly recommend that you go and take a look at that. Let's see. Now I got to find my link here. Here we go. So it's red.ht/virtops guide, and I will put that link into the chat here so it goes out to the world. So like I said, it's 110 pages-ish of just word vomit around all of the things and all of that. So hopefully it's useful to folks. Hopefully you find it interesting. We had a number of folks that were asking about it as they've been migrating into OpenShift virtualization, like, hey, what are the things I need to be aware of? What are the things that I need to do to operate my cluster on an ongoing basis? It's funny, and I'll, at risk of tangenting again, it's funny doing bare metal OpenShift is so dramatically different than doing virtual OpenShift. Because with virtual OpenShift, you assume that the hypervisor just takes care of everything, right? I have one network interface. My storage is coming from the vSphere CSI. I don't have to worry about configuring multiple network adapters and what's the multipath plugin, multipath D, what's its configuration like. You don't have to worry about all that stuff. It's all abstracted away.
The switches have an ISL. Is there bonding that I need to be dealing with, or even to a certain extent saturation of network adapters? All changes when you go bare metal.
So yeah, it never a dull moment, right? That's why we get paid the medium bucks.
That's it right there.
So I will share that link. Other than that, I don't think that OpenShift 422, the upgrade from 421 to 422, is in the stable path yet. However, I will admit that I have not personally checked on that in about a week and a half because, well, I switched to fast channel and upgraded my cluster. So do know that if you want any of the features or capabilities in 422, you can switch to the fast channel. You can update that now. It is a fully supported update. So if you have any issues or problems with that, you can always pick up the phone and call us. So with that being said, Chris.
Yeah. So yeah, there's a couple things that I had prepared here. See if I can get this. You know what? We're just gonna share the screen. Sometimes is a little easier. So yeah, I have a couple of things prepared, and really I wanted to take some time and hopefully elicit some questions from folks around some of the stuff that we are doing with you guys in the area of enhancements and all of that. But I'm going to start with a little bit of a quick overview for those that may not be familiar with what Portworx is. Now, Sully, a quick thing, because your video is now to my right, so yell to get my attention, or if there's a comment that comes in, so I don't clutter up my current screen with the video panels. So, like I mentioned, Ryan sadly couldn't make it with us today, but for at least a fun reason that he was at home recovering from a vacation, which is always, if you're going to be recovering from anything, a nice thing in my view. So, a quick thing about what Portworx does. Portworx is a software-defined storage layer that runs on I'm going to say most Kubernetes systems, we do use a kernel module. So saying any is you will find edge cases, but most Kubernetes infrastructure, and being able to use anything that is block storage underneath it to pull it into a storage pool to support any number of either virtualization or modern application workloads, whether that's databases running in containers, or of course with what we've seen happening with KubeVirt and products like OpenShift virtualization. We're seeing a huge uptick in that, especially with given some of the directions the industry has gone with we'll say acquisitions over the last couple of years has really, I feel like, changed that landscape, and we've been seeing some flux as people are moving things around. So that's kind of what Portworx is at its core. There's a couple of other we'll say products that can kind of bolt on there. Portworx Backup is designed to manage multiple clusters and backup workloads, whether they're virtualization or container based, and push them into object store or NFS, and then handle restorations, transformations, single file restores, that sort of thing is another thing that we do. Want to call out in our operations guide bit that we do have an OpenShift virtualization with Portworx architecture and operations guide. Hopefully that link is still in the private chat if you were able to share that, Sully. And
Share that, yeah.
So for those that need some additional bedtime reading, this is really a guide for how to operate Portworx and OpenShift Virt specifically. Okay, so with that, and I'm actually going to hit the thing that we wanted, I think, to talk about first. So I'm going to bounce around in this slide a little bit, but by way of some updates, I think one of the more interesting updates out of Portworx is Kube Data Store. One of the best ways to understand, I think, how Portworx operates is it's fundamentally hyperconverged. And we'll see how many Portworx people throw things at me after saying some of this stuff, but really at its core, if we think of it as hyperconverged, designed for local storage and to make it redundant, then suddenly the lens of what Portworx does makes a ton of sense. After all, if I have a bunch of physical boxes, I stuff them with NVMe drives, and it's fast, but it's not redundant. If I lose a box, I lose the space that was attached to it. So Portworx creates replicas that it can manage and move between different nodes, and all of that management stuff is really based on this hyperconverged sort of concept. Now that has some disadvantages as soon as we start talking about SAN architectures, because after all, in Everpure, I still got to get used to the name. The Everpure SAN appliances are themselves redundant. I forget what they're up to now in the actual measured statistics, but above 6 nines of data availability. And so having multiple copies that are attached to your OpenShift nodes is less than ideal, for reasons such as, let's say you do a write. Well, if I'm making multiple copies and I'm doing multiple writes against the SAN, I just have this huge amplification. I have east-west traffic that's happening to these systems, where I don't really need it. But at the same time, I don't just want to pass through the LUN from the SAN because it's more tightly coupled, and I lose some of the things that Portworx can do. Portworx, being software defined, for those that aren't familiar, can do some kind of fun things like migrating workloads. I could pick up a namespace and copy it to another Portworx cluster and do a DR plan, so it'll grab the data and all of the manifests, some storage operations, some security features, being able to allow users to clone workloads within namespaces, but actually making sure that they authenticate against the backend storage system. Some of these sorts of things. So I don't necessarily just want to pass it through and kind of tightly couple with the array, because I lose some of that mobility. So the answer to this is this new feature that we're calling Kube Data Store. And what it does...
Chris, can I interrupt you for a second?
Oh, yeah, please.
So kind of taking a step back. So within Kubernetes, and OpenShift is a Kubernetes, so I'm going to speak Kubernetes because this is a Kubernetes thing. When my application needs storage, I create a PVC.
Right.
A PVC is just a request for storage, and in modern Kubernetes, and by modern I mean everything after like 1.7 or 1.8, I think was when CSI became standardized and formalized.
Yeah.
It was super early. Random tangent. I was actually at the very first CNCF meeting when I was there representing the storage talk with NetApp, and we listening to some of the other representatives argue how Kubernetes doesn't need persistence. Like we should not have persistence at all inside of it. This was back
Those
in
arguments still persist.
yeah, and this is back in like the right around 1.0. So there wasn't even PVCs; it was pet sets, right?
Yeah.
Anyways, so I need some sort of storage, right? And in modern Kubernetes, we have a CSI driver that represents some sort of storage, and it goes and it provisions that volume however it provisions it. We don't know, we don't care.
Right.
And it maps that volume over to my request for capacity. And so with a system like Portworx, by default, the way it works is effectively by having a software-defined distributed storage system that creates a shared pool of storage. So it looks like one thing, but when I write to it, it actually just it mirrors that data across multiple nodes in the cluster. Please correct me if I'm wrong here.
You're and not unlike how a SAN works, because if we think about it kind of in layers, right? The PVC is fundamentally is really that PVC object plus a provisioner, which is a controller, right? And so when your application goes to a storage class and says, I need a bit of storage, and you create that, the PVC is created, it goes to whatever the backend system is. And by the way, Portworx Enterprise still just uses CSI for that provisioning, because why wouldn't we? CSI is the standard. And so it goes to the backend storage system and creates the thing. Now, with something that is I'm going to say tightly coupled to an array, the way that would work is you go to the provisioner goes back to the array, and it typically creates a volume, which it then presents as a LUN, which it plumbs through, hence the multipath deconfigs, those sorts of things that need to be in place first, and then it attaches it as a persistent volume, connects it to the PVC, and poof, your pod formats it, and then your pod's happy. It has its bit of storage, and of course, CSI as a spec handles other things like failover. If I lose a node, let's detach that LUN and reattach it to a different OpenShift node. Portworx is an example of a term that I've heard a bit, so we'll see how it hits the audience. But container native storage. So because if you think about how a SAN works, right? We created the LUN, we presented all of that type of stuff, but it's external. And the SAN is 100% being redundant, whether that's RAID 10, whether it's erasure coding, whatever the thing is. But it's essentially acting as the service to hand you a bit of storage and says, you have multiple ways to get to me, I'm redundant. Portworx Enterprise, in kind of its legacy of being hyper-converged, said, no, instead, I'm going to say in quotes here, the SAN appliance intelligence is running inside of the Kubernetes cluster. We have pods that are pulling in essentially what we treat as dumb block volumes and handling that resiliency. So now it's still CSI. When your PVC says, I need a bit of storage, it's still a provisioner. There are CSI controller pods running in the namespace that we deploy that then create the underlying Portworx volume, create the PV object, and attach that to the PVC, which then goes into the pod. The difference is, of course, in the transport, it's using essentially a local device that is, think of it more, it's essentially a kernel shim that is sitting in the dev file system that's acting as a virtual block device that is then routing and creating multiple copies of the data on the back end. Now that, of course, is configurable. I'm kind of speaking in generalities here, but it's acting as the SAN. It's doing a replica factor and then is handling the failover if you lose a node to say, well, now the block device can be over here. It's also doing kind of, I think, architecturally some kind of fun things, because if I'm in at that level, I could also say, you have local block devices attached to your OpenShift system, and you have an application that needs some form of shared storage, say RWX. Ordinarily, that wouldn't be possible unless the pods are co-located on the same box. What we do is say, well, let's spin up a little NFS service with a cluster IP for failover reasons, and we can represent the storage out over an NFS protocol entirely internally with the cluster, so multiple pods could access what ends up being local block storage on a particular pod. So I say hyperconverged, but don't misinterpret that. We don't have to. It's ideal, but we don't have to co-locate the workloads with their actual underlying storage. May have been maybe more than I needed to say about that.
Well,
I find the subject fascinating.
I think you also hand waved over one of the really cool things about Portworx, which is Stork.
Yes, I did, kind of putting it in one thing, which is and Stork is an orchestrator runtime for Kubernetes, a storage orchestrator runtime. There's actually been there's two ways that I've seen the acronym used. So I almost wonder, is it one of the, what's the term when you come up with the initialism first and then back it into an explanation? I don't know. That's just conjecture.
A backronym instead of an acronym.
Is that it?
I don't know. That's what I'm going with.
But that I hope it is. But the job of Stork is to, I guess in a lot of ways, it's providing a couple things. One is it's a scheduler extension that can do more than what the Kubernetes scheduler does by default. So it has knowledge of the storage system, so it can co-locate in the case of hyperconverged systems. So, hey, I'm scheduling a new pod. It'd be great if that pod ran on a node that had one of the replicas of my data, so I don't have to use the network. But it also is a set of custom resource definitions to extend past we'll say what the CSI spec delivers, because it's really the only way to do it, because there's no CSI spec for doing DR. There's no CSI spec for say having a rules engine automatically grow a volume or things like that. And so Stork has a number of a number of these CRDs to do those sorts of functions. Which, by the way, as an aside, I really like. Instead of having an external engine interface where DR has to be an API or something else, when people ask me, well, how do I automate this? Well, the same way you automate anything else. I had, I guess it's been a couple of years now, an interesting KubeCon talk about using some of these migration tools and CRDs as a way of doing database integrity test validation, and it's plugged 100% into Argo. Because why not? If everything is a manifest, my DR schedule and even the triggering of DR events can be part of a GitOps pipeline, which I feel like is the right way to do this. So that's really Stork's job, is to do some of these extensions, do the scheduling, and some other bits are, of course, it can do some fun placement stuff, like even how it handles the replicas themselves. If I have a 20 node cluster, chances are those aren't all in the same rack. It'd be really grand if I respected the labels and said, I want my replicas to be in different racks, different rows, different AZs. If you happen to be running, something in the cloud, or you have the same concept inside of your data center. So,
yeah, and I really appreciate the scheduling aspect, because you said, I want to put my pod that's using this PVC onto the same node that one of those replicas of data is. And yes, one of the benefits is it's one less, network, that much less network bandwidth having to replicate it one additional time. But it also means you get local performance. Right?
Yeah,
you're
which
not having
makes a difference.
Yeah, you're not having to wait on multiple replicas and acknowledgments and then returns in order to do all of those things. It's only however many the replication is configured for. So it's just one less thing to go wrong, that much less resources that are being consumed, particularly on the network side, where with software-defined storage, which I think most all of them operate on effectively the same principle, which is creating replicas of the data in order to protect it. The network is always going to be the bottleneck for performance.
Yeah. And even just, networks are fast, latency is low, but that stuff adds up, especially when IO patterns tend to be more transactional, closer to synchronous. I can't do the next thing until I hear back from you. Then suddenly the amount of latency that we have really starts to matter. and if we go over the network, we're kind of throwing away a huge advantage of the, I have stuffed a bunch of NVMe drives in a server, right? That we have. So for all of that explanation, I do like that as a concept. And by the way, and this is a little bit of an aside, but we have some newer reference architectures with you guys. I had a session at Red Hat One around 2-node arbiter setups. So having 2 OpenShift nodes, a small arbiter node, and only having storage on 2 of those systems for, of course, edge and smaller deployments, where suddenly local storage makes a ton of sense, because how many stores with point of sale systems are going to bother with a rack and a SAN and those sorts of things. So if you haven't seen it, I think it's worth testing that out, and that's a joint between us and the Red Hat folks.
I think that same architecture supports true 2-node as well, because we introduced 2-node with Arbiter in 420, and now with 422 we have 2-node with failover TNF.
Oh, I don't think we support that yet, because I think we need the third leg for something. Although we can have that be a virtual machine, but that would be a great thing to double check on for me. So, but yeah, if I heard that was something you guys would be doing back then. So
yeah,
right.
There is a caveat with so TNA 2-node with Arbiter. I believe it's tech preview or dev preview to add additional worker nodes, but with TNF you cannot add additional worker nodes.
Oh, okay.
So yeah,
since we're the word of the day is tangent. How's resiliency being handled if you don't have a witness? Is there something that they're pinging in order to break those ties? Because my mind immediately snaps to, okay, the network gets severed and you have a split brain problem.
Yeah, it's RHEL HA.
Okay.
So yeah, it's not keep alive D. Why can I not think of what RHEL HA is? I can never remember what the underlying thing is. Anyways, it's RHEL HA that works on the 2-node side in order to determine which node has failed, and then declare basically which one is the surviving, quote unquote, surviving member, and therefore has quorum.
Oh, that's nice. Yeah.
So we have a question from Pursue. So what things break if Stork is misconfigured or not running?
Stork is misconfigured or not running. So Stork is a series of 6 pods, so it kind of depends on what breaks. It is a scheduler extension, so you'll notice when a pod shows up, it changes the scheduler to Stork, and I've broken it before, and so the main thing you see, a pod doesn't schedule if the Stork scheduler controllers are broken. There are, like any system, there's 101 different failure scenarios that we could potentially go through with CRD controllers that I'll talk lightly about. But that's kind of the main one. So obviously these run as a deployment with 3 pods at a minimum that are acting as the scheduler. And by the way, editing the manifest and changing the scheduler, it all still works, right? There's nothing stopping you from using a default scheduler, your own scheduler, or anything else. And if for whatever reason something's failed. That being said, I've only seen it fail once, and I kind of I'm not going to say deliberately broke it, but that our initial conversation about me breaking things in the lab, I'm the only one that I've ever talked to that's actually broken that thing. So for what it's worth, so that's going to be the first thing. Pacemaker. Oh, see, this is why I love having an audience with a that can mention this stuff.
I did a search on it while you were, because it was like, I should actually look that up. Yeah.
Oh, this is the time I need glasses. Okay. But the other thing that can happen is, because Stork is responsible for a number of those other CRDs, so other failures that can happen. Let's say because I did this, you deliberately go in and you kill the access of the Stork, the Stork controllers, not the scheduler controllers, but the Stork controllers. Then which I did at one point because right, least privileged idea. I wanted to, and we do support that, and it was called out in the documentation. But you'll have some things like, well, Stork needs to the controllers need to access a particular resource in order to do replication for VMs, and if it doesn't have that access, it fails. If the pods themselves aren't coming up, then essentially the controller can't fill any of those additional requests. Now, all of this is kind of getting to the point of, does anything happen to the data path? And the answer is no, because Stork isn't in the data path. So essentially, you just lose those management functions. The data path is controlled because, again, we're acting kind of like the SAN running inside of the cluster. The data path is a set of pods, and those can absolutely, die, be broken, whatever the thing is. And the typical pattern is it's one per pod.
If I'm summarizing correctly, so if Stork isn't running, we can't schedule new pods because it's a part of the scheduling path. And makes
unless you're using a different scheduler for whatever reason.
Oh, good point. So I cannot schedule new pods that are using a Portworx PVC.
Not even that. It'll still work. It's just Stork because it's actually a scheduler called Stork. And if you use it and there's nothing to fulfill that scheduler, the pod stays in a pending state. If you immediately go in and just change it, but what you lose is it ignores the underlying replica topology of the PVCs. And so it just puts a pod somewhere, and you're likely going over the network if it's a sizable cluster.
But any pods that have a PVC already mounted, everything's good there. It's going to be behaving as expected. If I stop a pod, it doesn't prevent it from unmounting the PVC or anything like that. That still functions.
Right, because those are all CSI functions, and there's actually a set of CSI pods that are in there. We're all friends here. Let's see if I have this up. Okay, so this is a 3-node Portworx cluster. This is a compact OpenShift cluster. So there's only 3 nodes. So certain things would be larger in an environment like this, or would have more horizontal scaling, like particularly this PX cluster. This is the heart of the system. This is what's actually in the data path that is taking disks and distributing them. Everything else that I mentioned, the Stork scheduler, this is the controller that I mentioned. This is what is servicing the CRDs. If we do, oops, shouldn't have done that.
There's a lot of those. We might need to make the text a little larger.
Oh, thank you. Let me see if I can figure out how to do that. There we go. No, we don't need this. So you see these the CRDs that I mentioned. This is it. So you don't have the controllers. This is what stops working. So because there are kind of some fun features that I sort of glossed over, like being able to take a snap of all of the manifests and all of the data and then push that into an object store. Backing my local snapshots into cloud storage, things like that. Okay. So we have these list of pods, and some of the other ones that you'll see are key value store. This one fails, and essentially it goes into a run flat mode because this is like etcd failing. So things still run, but it needs to be recovered before we provision more things, and it doesn't tend to work well without it. The Portworx API, really just a pod to have an API service that is local to the cluster. So this is really just pointing at a particular port on these cluster services themselves. The CSI controllers, we mentioned we use CSI for actually the fulfillment. That's what these boxes are doing. The plugin and plugin proxy, that's for the UI integrations with OpenShift, which I have some slides on. Of course, the operator, because Portworx itself, I actually think this is kind of neat, because if there's a thing about Kubernetes I love, it's operators. because Portworx installs an operator that's actually in your guys' ecosystem thing. And then we add a CRD that is a storage cluster. That's how Portworx is installed, right? It has, what do I want my name to be? What, if I can find the image in here, yeah, I need to make it bigger. There we go. That it's running this particular version. So how does an upgrade look? You increment that number. It goes through and orchestrates the whole thing, similar to any other level 5 operator with how they work.
You can do that through the UI or through this the
I should be. Am I? Am I in the UI? I need to get this refreshed. Funny story, because we actually use, as you can see, VNC in here because this removes any browser compatibility problem that I have. So yeah, I can jump into my installed operators here, and with any luck, see my Portworx Enterprise operator, which adds the CRD for a storage cluster, which is actually just right here. So it is just an object that I can manage in the GUI. I tend to be more of a CLI guy, so you'll have to forgive me for going there first.
The funny part with OLM and operators is when you create the CRD, you only get the wizard the first time you create it. Anytime you edit it or change it, you have to do it using YAML. So there's a question here from Olu. I'm not going to attempt to pronounce the username. How does Portworx handle storage offload during migration of virtual machines to an OpenShift cluster?
So I want to make sure I understand what you mean by migration. If we're talking about the ingest from an alternative hypervisor, or are we talking about something else?
In my mind, so at Summit, we started talking about offloaded migrations using MTV, the migration toolkit for virtualization, which is it's a storage vendor dependent thing.
Yeah.
So
that's ends up being true with us because quick level set. You can use MTV over the network for just about anything, and Portworx has nothing to do with that, right? Because you're pulling it in from the network. It's going to OpenShift. OpenShift says I need a PVC, and we are a happy cog in that particular environment, and that's it. Now, if you are running VMware, and if you are running on an Everpure array, well, instead of let's go up over through the network, and pull things that way, instead, what we're going to do is do an X copy on the back end. And of course, by X copy, I mean the array primitive. So we're going to tell the flash array, well, these blocks also need to belong to this particular PVC. This, by the way, is under the covers a two-step process, because if I have something like, say, a vvol, well, that's nice and self-contained. I can easily transfer that. Remember when I had that conversation about something being tightly coupled, and we have one LUN per storage bit, per PVC, we'll say. That's how I convert it the first time, and then I ingest it again into Portworx. But this ends up being pretty fast, and if anybody really wants to deep dive into this, we have a guy on our team, VJ, who spent a ton of time with this tool, benchmarking, messing with it, and the whole nine yards, and would be able to go in with some, I'd say, more significant depth. But really, this is to just make this whole thing faster, because after all, if we're transferring, a petabyte of virtual machines over a network, no matter which way we cut the cake, that's a long process. And it complicates our world, especially for some of these larger virtual machines, when my window has to be larger, or I have to do something fancy. There are a couple caveats with this. For instance, if I'm doing like a warm migration, I do the first copy, then those subsequent copies do need to be over the network. I don't have a way of doing an incremental X copy multiple times. So again, there's and I think that's probably the big caveat that I know of.
So is that so I'm trying to think of how to phrase this that's not confusing. So Everpure uses Portworx CSI as the CSI driver for both Portworx SDS as well as FlashBlade. I think it's still called FlashBlade. on the back end?
So no, FlashBlade is 100% file and object. And
Okay, so flash array then.
So flash array, yeah.
Okay. So it's Portworx as the CSI driver, regardless of whether you're using Portworx SDS or flash array, Everpure flash array, which is a traditional storage array. So with this Xcopy offload, does this only work if I'm doing flash array on the source side and flash array on the destination side, or can Portworx SDS also take advantage of that?
So Portworx you're only going to get this if you're running flash array on the back end.
Okay.
Portworx SDS doesn't really need to for the most part, but the trouble is it doesn't have a mechanism to say you're running a NetApp underneath Portworx Enterprise. It doesn't have a way to talk to the NetApp to do the appropriate Xcopy in order to accelerate that ingest. But because we're already managing Portworx, in practice, you don't really need it, because what would tend to happen is if Portworx owns the storage and it can migrate around replicas, then but that's kind of a different migration. This is the initial ingest into the system. The short answer is Portworx Enterprise, the SDS side of things, doesn't have a way of interfacing. And so Portworx Enterprise, by the way, can still do this, because there's two things, right? You have Portworx Enterprise and you have the product, and I'll say, because we're all friends here, maybe the unfortunately named PXCSI, because yes, it's a CSI driver, but so is everything. And so PXCSI is really what comes with the array, and it does that tightly coupled, you need a PVC, I'm going to create a volume on the array. Portworx Enterprise can, by the way, do the same thing. Yes, it can do software as defined, but right alongside that, it can do those pass-throughs and they can coexist. So it's good to make sure that you have that distinction in the Portworx product portfolio, that there's Enterprise, which can run everywhere. It can run on top of NetApp. It can run on local storage. It can run on top of pure flash arrays. And then you have PXCSI, which is a flash array only CSI driver for Kubernetes and Kubernetes variants, and of course OpenShift being the lion's share of those.
Yeah. So circling back around, so with Kube Data Store, how does that fit in?
So Kube Data Store is because by this point, hopefully people have this idea of where, the good, the bad, some of the landmines are showing up. And let me find the right slide for this that I want, because there's a good visual. Okay. Apparently having trouble with that.
Glad I'm not the only one who has trouble finding the
right visual that I want to point to. So, with this shared nothing architecture that I mentioned before, this is sort of the visual for how that looks, right? I have an app. It has multiple replicas that it has across worker nodes. And the trouble is, if this is all the same underlying SAN, then I have some write amplification and all of those things. And by the way, the default stance is we expect with Portworx Enterprise, the SDS, product, the LUNs don't move. They don't need to move. We don't want them to move. They are part of the box, even if they're part of a SAN. That attachment ends up being static, and we call this, by the way, static pools. The pool is of course right down here. With KDS, what we are doing instead is saying, well, why can't we have just a REPL1 pool? Now, by the way, with static pools, a single replica works. Why is that potentially a bad idea? Because they're static. They don't move. If I lose the node, even if it's SAN attached, the storage went with it. I've just created an outage. So what KDS is at its heart is the ability to take one of these pools with only REPL1 volumes, and I don't need anything more from a SAN resiliency standpoint, because after all, SANs are resilient, and be able to move the pool to a different node. So essentially, this is an answer to letting REPL1 volumes be resilient. And kind of a fancy name for it. So you can imagine how this changes all of our discussion before, because now there's no write amplification. By the way, what just happened here, you'll notice we do still try to co-locate, but in this case, we couldn't. Do we have east-west network traffic? Yes, we do. Because app3 needs to access its data on pool 2. Now, this, of course, means that I do need a way to non-disruptively move these pools. I don't have a picture of that, but move these pools back and forth to different nodes non-disruptively. And that's part of what KDS does. KDS will also automatically rebalance the pools if it notices too many things getting out of whack. Like you have, 100 PVCs attached over here and only 10 over here. It will move pools around to try to even things out automatically. This, by the way, does have some caveats. It's pretty fast on a failover perspective, but if you think about how replicas work, the data is already there and already attached. This will never be as fast from a storage failover perspective as just local connections, but it makes flash array administrators a lot happy because we don't have all of that write amplification and east-west traffic that comes with HCI systems. So hopefully that gets at the heart of what Kube Data Store really is. By the way, another name for this would be dynamic pools. Now, this does support both virtual machines and containers as workloads as well.
So if I can recap, so standard Portworx deployment, I'm doing HCI, right? So I have servers, whether they're virtual or physical, that have disks attached to them. Portworx consumes those disks and using replication of the data creates a shared pool of storage that is highly available. It's resilient.
Right.
I can use an external storage array to provide those disks to Portworx SDS in that HCI-like mode, but doing that is expensive because the storage array itself is protecting the data through some sort of RAID probably or something like that. And so I have, if it's RAID 5, for every one write I make, it's 3 IOPS, I think.
Yeah.
It's been a minute
But
since
more than that, I do it 3 times because every write
Exactly.
needs to go to multiple replicas.
And so you could use a enterprise storage array or some sort of external storage array for that, but you'd want to do it in like a JBOD mode or a RAID 0 type of thing, I think. Which has its own inherent risks. That's a whole architectural conversation.
Right, because then if the shared thing dies, I'm dead in the water no matter what. Because if I have multiple replicas on a pure array and the pure array goes, I have a problem. And so there's a lot of reasons, and in fact, a lot of our customers, they do run multiple replicas on top of flash arrays. And the reason they do it is fast failover resiliency and because KDS is new. I'm curious how fast the uptick of this is going to be with folks. Because it's kind of it was definitely an inefficiency when it came to SAN architectures.
So, and just to make sure my understanding is correct, so with KDS, with Kube Data Store, it's not like you have pool 1, pool 2, pool 3. There's not one LUN that is mounted to each one of these 3 nodes, and that one LUN creates a shared data store. Rather, this would be 3 LUNs. They're accessible by all of the nodes, but each one is only being used by one node at a time.
That is correct.
And when I create a PVC, something inside of Portworx says, oh, I'm going to choose pool 1. It provisions that PVC inside of pool 1. And pool 1 is always mounted on, to make things easy, node A.
Yeah.
If by default, if node A fails, then Portworx takes action to remount LUN 1 on, say, node B.
Correct.
And then re-ingest or rehydrate. No, that's not the right term. Anyways, basically reserve all of the PVCs that were on node A, but still on LUN 1 now through node B.
Yes, that's that slight tweak, since we're I guess this is an ask the expert sort of thing. The LUN isn't connected to all nodes at the same time. This actually follows more of a CSI pattern. So it's only pool 1 is only connected to node 1, and when the failure happens, it is talking to the array API in order to represent that LUN, the unit number representation of the volume, to a different node. And that's important when it comes to the next set of questions, because this is a what do we call it? Early access, a directed availability. So essentially, we want to talk to you before you implement it. And this today is for flash arrays and OpenShift only. Why is that? We have to be able to talk to the API in order to do the failover. And now in the future, that's going to change. Now, for forward-looking things, I'm going to have the caveat here of saying you really need to talk to one of our product managers, and they can give you a full rundown. But as you can imagine, in the future, looking at extending this, and it's not too much of a stretch to say that extending it through other people's CSIs makes a lot of sense. That we're going to see this act, and what I think is probably the most exciting is seeing this act as really being able to manage multiple arrays in the future. Because after all, without a lot of the downsides that I was introducing, everything being static, no, I can just provision from different arrays. I can handle failover. And because of this inherent thing that I mentioned very early on, being able to move replicas between pools, I can move replicas between pools. So this idea that I can take a workload and move it between backend systems, and suddenly I feel like we're getting a lot closer to where we'll just say for the longest time, the industry leader in virtualization was when it comes to workload mobility. Now there are other solutions to do the same thing, right? I don't want to discount storage migrations that are happening entirely, inside of your guys's OpenShift products as well. But this would be another tool and way of handling that. That's kind of on that software-defined storage layer down, if that makes sense.
Yeah. No, I think it's really interesting for a number of reasons. And storage is hard, right? My career, you could argue, started as a storage administrator, right? And I spent my whole life with storage, right? We still have people, that both on the industry side as well as in customer organizations, that our whole job is storage. It's hard. And it's especially hard with things like virtualization, where I'm concentrating all of those IOPS and all of those gigabytes in one place. And so there's a reason why storage arrays are the way that they are. And scalability is a thing. Well, the way that PVCs work and most CSI implementations work is each PVC is a volume on the storage array. And storage arrays just, they're not typically architected to handle thousands or tens of thousands of volumes. And certainly not when we're operating at the speed of Kubernetes, where I'm mounting and unmounting them, constantly, all of the time. The API servers aren't there. So something like this brings that functionality of Kubernetes native storage to any storage array.
Right.
Which I think also has the benefit of it continues to provide the isolation between the layers. The way I look at it, so OpenShift, right, 6 years ago, we introduced vSphere IPI, right, with OpenShift clusters. And it took a while for adoption to pick up, because there had to be this negotiation and trust building period for the virtualization team to allow the OpenShift team to have access to the APIs and the permissions to provision their own virtual machines. And storage is the same way, except that we storage administrators tend to be a very conservative bunch, if you will.
Yeah.
Which makes sense. We catch a lot of abuse, right, from the because performance. Anytime there's a performance issue, it's the storage team. It used to be the network team. Now it's the storage team.
Yeah. Well, you even think about some of our earlier discussions with Kubernetes and some of the, I'm going to say, more fear of putting stateful workloads inside of Kubernetes, because storage is the thing you can't get back. I mean, how easy is it if the Kubernetes cluster has no state, where the only thing is etcd, to migrate to different clouds, to have multi-region configurations? As soon as you bring storage into that, the world changes, because locality matters. How do you really create distributed data systems? And speed of light starts to matter. And suddenly, all of this, inter-region microservices stuff tends to, I don't want to say fall apart, but it gets a lot more complicated. And you add to that you can't lose storage. I mean, having a data loss event is a huge deal inside of a company.
Yeah.
A lot
Rule
more
number
so, I
one of
think,
storage is you will never lose lose data. That is
right,
not even rule one. It is rule zero.
right. Because it shatters trust. And so I think there's a lot of good reasons for that, that conservatism, by the way, because things like API access and stuff, man. If I was by the way, one of my favorite features, that I don't think gets talked about enough on an Everpure array, is this idea of I think they call it secure access workspaces, but really the underlying commands are all realm commands. And the idea that I can carve off a portion of the array, including network adapters, whatever else, into an isolated environment, and then have specific API keys, maybe even with specific API endpoints, that I can hand to somebody because of that trust issue. If I'm the array administrator, I think I would be crazy to hand me, the Kubernetes administrator, an API access to create and manipulate volumes. Like, no. Let's give you a sandbox with limits around it, and you can build all of your stuff in that, but you will not be touching my physical SQL servers or the other things that are running on the array. So if you haven't heard of this, I would encourage everybody to just implement it. But
yeah, it's like, here OpenClaw, here is full access to my email, and all these things. Go forth and make my life easier, and send out a bunch of emails that I didn't ask you to. And
yeah. Now, that thing we were talking about beforehand, that is how I had those Postgres clusters be deleted, except it was Hermes, and it was doing some SRE stuff, and it was trying to do a migration. And the funny part is, I didn't even give it access to the cluster. And exactly, anybody who's had a conversation with an LLM knows how this goes, where it's migrating. It says, oh, I need to clean this up, and I watch it. Delete Postgres cluster -- all. And the horror. Well, it's already done. It's the command's in there, and then there's this. I post a screenshot, but there may have been some language in there that is not suitable for all audiences. And I'm talking to this LLM, and it says, and of course, I'm very sorry I deleted those. You told me not to. I didn't even have credentials, but I needed to delete them in order to clean this stuff up. So I went and found the credentials that you had saved and forgot about over here, in order to delete everything. But I'm very, very sorry. Let me try to put it back where I promptly said, no, you've done enough. We are going to do my own handwritten DR plan for this particular one.
Oh, so it's funny you say that. Literally yesterday, I was chatting with another Red Hatter on our internal Slack, and they were asking about OpenShift MCP. And so Lightspeed now ships with its own MCP server. And then there is the standalone OpenShift MCP server, which you deploy using a Helm chart. And so I was showing, like, oh, look, I can go into Lightspeed and say, show me all of the, tell me about the VMs that are running in this cluster. And then I did the same thing on my Claude Code instance on the desktop using the standalone MCP server. And then I said, Lightspeed, migrate this VM to a different node. And it said, oh, I can't do that. I don't have permissions. Here's what you need to do. Claude Code, on the other hand, which was using a read-only instance of the MCP server, said, okay, and then proceeded to switch from MCP to running an OC command to do it. So in typical fashion, it found a way to succeed, very much to your point of, like, yeah, remember these credentials you had hidden away that you forgot about? Yeah, I can still do this, and I'm going to do it. And it in my mind, immediately it jumps to, okay, like the whole thing with LLM sandboxing or agent sandboxing, and how do we prevent it from accessing things that we don't want it to, and how do we give it explicit, permissions and not let it violate those permissions. And it's a brave new world, a brave, scary new world when it comes to all that stuff, for sure.
Yep, time to pivot to a little bit of security. We'll see. So one thing I do want to mention as well, because I think this is also pretty cool. I mentioned, so I'm going to have to backtrack a little bit, because I mentioned I'm kind of a CLI guy, and sometimes have been accused of saying, no, the right way to do everything is with the CLI. Well, that's not the reality that we live in. And even I, reach for UIs sometimes when I'm that I don't always admit, and probably need to, maybe only admit in therapy. So UIs are important. I think especially in order to make systems accessible, we kind of need them. So I say that grudgingly. You can hear it in my voice. As a guy that spends his life like automating, OpenShift and Portworx installations and configurations, but we have been putting a lot of development time into UIs, being able to have dashboards for information. So, because of course OpenShift has a UI, and most of the things that you interact with are Kubernetes objects, PVs, PVCs, storage classes, storage profiles, and that's great. But we are missing the backend bit, which is what Portworx handles, the replicas, like all of that mapping, and as well, a lot of our CRDs are just manifests. So unless somebody goes and codes the thing inside of the UI, the best you have is YAML. So what these dashboards, I'll go on to the actual bit, is providing information. But what some of the other things that are coming, I got to find this here. I went to this too soon. There's a lot of, is being able to do, say, DR plans, migrations entirely within the UI with a plugin inside of ACM. So we're seeing not only performance dashboards from the storage perspective, being able to affect some Portworx changes inside of individual clusters, because that, after all, is where Portworx runs, but also some of these UI hooks inside of ACM, which is, of course, managing multiple clusters inside of an OpenShift ecosystem, and being able to plug into that to configure and execute DR plans. Or it was an interesting demo where one of our guys, in conjunction with Red Hat, took a workload from an on-premises OpenShift cluster and migrated it to Rosa and AWS to, I'm going to forget the name of all of the different hosted control planes in the clouds, but then to the Azure version of it, and then to the GCP version of it, and then back on premises, all using these migration plans and having the app bounce around, and entirely using ClickOps, which feels like kind of the moment where some of this technology, I think, is really going to arrive to be accessible to a lot more people.
Yeah, it's funny because I've been doing Kubernetes since long before it was 1.0. I remember having to compile SkyDNS and add it into the proto clusters back in the dot something.
So when it didn't even provide core or.
So sure, there's those of us who've been doing it for a while, and we feel comfortable with the YAML and all that other stuff. And my thing is, Kubernetes has become wildly successful off of like the efforts of those folks, right? The quote unquote 10xers, right? The people who are leading that. And I think the next stage is the maturation, where it's the next set of folks in the bell curve where it becomes more accessible. And I don't have to be a tier 2, tier 3 administrator, a senior administrator or something like that to really be capable and competent with Kubernetes. Instead, I can be that junior administrator, and I can be effective with what I'm doing, and I can do the ClickOps thing. And then as I gain that confidence and that knowledge, it's an easy transition, because underneath the covers, it's all the same thing. It's all just YAML.
Yeah.
Which is one of the things I love about GitOps.
Yeah.
It's all just YAML. That
declarative state. And I'd even say, because it's absolutely like maybe junior administrators, but I think a lot of it ends up being a breadth and a time problem, because the reason I'm comfortable with YAML is because everything in my life revolves around YAML and Kubernetes. I don't have a thing that I don't have to administer VMware or Windows or anything outside of Kubernetes. That's my life, and that requires some time, and I feel like specialization. And I'm not sure everyone, even in a lot of places, necessarily gets to that point. There's always going to be efficiencies of having specialists, but having this be accessible to to non-specialists, to people that are still learning, to people that are never going to, because it doesn't even make business sense for them to get to that level. Having this sort of accessibility, well, makes it more accessible. If a manager or my backup person can go into a dashboard, I get more vacations, right? Where I'm not, by my phone.
That's one of the things that's really exciting to me about like the LLM integrations for things like, augmented by skills for teams like developer and teams, right? They want to write code, they want to fix bugs, They want to implement features. They don't want to have to care about OpenShift. They don't want to have to care about what's a deployment and all these other things. Maybe somebody on the team does, but by and large, the vast majority of them just want to say, I wrote this code, now go and build it, test it, and do all these other things. And it kicks off that whole process without them knowing about it. They go and say Claude or Chat GPT or whatever, do this thing. And it interfaces with the cluster. It does all of those things. And it comes back and says, oh yeah, it looks like it was great. Let's ignore that it likes to manufacture tests that, if true equals true, stuff.
Yeah.
But that's the dream anyways, is lowering the barrier to entry. The whole if you build it they will come isn't real, right? It needs to be a usable system. It needs to be an accessible system.
Right. Yeah, just ending on kind of, here's your API endpoint, have fun, I think is not going to work work everywhere. So
our Hope 9, any idea if the slide decks from the what's next and what's new are going to be released? Oh, I'm surprised they haven't already. I mean, look at the man, I can't type. Oof. Yeah, it looks like they're on the landing page. Let me put that into the chat here.
Oh.
Although it does look like, to your point, I see you're asking about the slide decks. It just looks like it's the recordings that are posted on the landing page. So I'll ask the team about that. I'll find out what's going on there. Sort of background. I seem to recall recently that we were requested to stop using SpeakerDeck for those and figure out a different place to host those slides. Our Hope 9, if you'll email me, I'll shoot you a PDF of the slides if you need them. So Chris, I know it's been a long and winding road. It's been a fun conversation. I've enjoyed
the best
it.
Kind, right?
Yeah, I've enjoyed it very much because it pokes at all my buttons of storage and virtualization and LLMs, which I feel like are more and more of our lives every day here recently. So it's been super interesting, and I've really appreciated learning more about these things. I'm happy to see KDS coming into fruition and learning more about that. I think it's really cool. I'm excited to see it.
We actually have I think a hands-on lab that's going to be coming up, I want to say in a month or two, that's actually going to have people run through an OpenShift and KDS cluster with a virtual flash array. I kind of love these sorts of hands-on labs because really they're educational. It's trying to cut through, like actually failing something over and actually migrating a pool and running the commands that do that. I think is invaluable. Just to learn about it. So keep an eye open for that. It's in development and I guess a little bit of testing at this point. I want to say they'll post it on portworx.com. I should probably know this, or reach out to me. I'm ccrow at portworx.com. I probably should have put that in the in my name there.
I usually it's only Jonny and I that are willing to put our emails out there for the whole world. So don't feel bad.
That's what's the worst that's going to happen? We're going to test the work spam filters.
So Noah is asking a question here. So we use bonded 20 gigabit network adapters with separate VLANs for management, Portworx replication, and VM traffic. can heavy replication still increase app latency, and how can we mitigate it without dedicated network adapters?
Ooh, good, good question. So, depending on, absolutely, 20 gigs is a lot. So, when you think about what a storage array and underlying storage systems can really do, um, that's a lot to have at each level. Can you saturate it? Absolutely. My gut would say you'd really have to try, but it will absolutely increase latency, and very much kind of on a hockey stick, right? Because the way those replicas work is, and it kind of depends on how things are deployed, but the way those replicas work is two of them have to be synchronous. So I can't acknowledge back to the original application unless I have two copies of your data. Otherwise, a power outage at the wrong time, we have a real problem, because with REPL 2 and 3, we don't need a local journal in order to capture that stuff. Turns out with REPL 1, we do have a local journal too, like any file system would. So how do you handle that? Well, before recently, the answer was build a bigger pipe, which is an unsatisfying answer. You can, of course, use any traffic shaping tool that you have. There have been some changes inside of the app I/O control features that can adaptively. Is it adaptively? It actually might be a set, but where you can actually shape the replication traffic. Now, that's not a perfect solution, because at the end of the day, you have 40 gigs of bandwidth, and depending on how you are balancing that, because bonded in my mind could be, source dest IP hash, so it's at best an avoidance algorithm. It's not adaptively moving things back and forth. So depending on those factors, you may always have a problem where I said build a bigger pipe isn't necessarily the best answer, but it's oftentimes one that happens. What I would say is for bonded 20 gigs, that's a lot. And many times, if you have sizable clusters, that's really not where the bottleneck happens, because that's on a per node basis. Bottlenecks tend to be at the SAN, which probably also only has 40 or 80 gigabits running to it. And if you have 20 hosts, can easily saturate it. You want to handle that at the array level. Look at the array's QoS features. And then oftentimes, again, depending on how the bonding is working, the switch ISL. Because if the switch ISL is limited to 1 or 200 gigabits of bandwidth and you have a bunch of things, they tend to be oversubscribed. Those are trickier to find, but it tends to be where I see bandwidth pinched. And yes, unfortunately, all of those could potentially increase latency. And that's why I would say moving towards, and I don't see something specific about your architecture there, but with hyperconverged, you need big pipes. If you're using SAN attached, that's where I would move to more efficiencies. Look at KDS. Look at, with your bonded connections, I was a Cisco guy back in the day, so I'd say something like, bonding with VPCs to keep pressure off of the ISLs, things like that. And then at the and talk to your storage administrators, because many times if you're using NVMe over TCP or something like that, you actually want dedicated VLANs for the A and B side, again, to keep traffic off of the ISLs. So that's kind of a long-winded way to say that the best answer. There are some traffic shaping tools with app I/O control. I wish I could just tell you the commands off of the top of my head, but I can't. I've only seen the PM transfer of information so far. So feel free to follow up with me or someone from Portworx afterwards. But I suspect if you're really at that saturation point, that on a single node, that it's probably more of a balancing or kind of pinching somewhere else.
Yeah. I think my thought is, let's ignore all your valid comments about other bottlenecks and other areas where you're likely to encounter issues. So let's take it at face value, right? There's 40 gigabits of throughput and there's no free lunch. So if you're filling up 40 gigabits and you end up with management traffic is relatively minor, so I'm going to ignore it. So basically storage replication and virtual machine traffic, they're always going to be competing with each other.
Yeah.
And so stealing throughput from storage replication is going to increase storage latency for all of the applications. Stealing throughput from VM traffic, right, application traffic is going to affect, the applications and what they're doing. So it becomes you're robbing Peter to pay Paul type of scenario. And so if you want to avoid that, you have to use dedicated network adapters. Even if you had something like VMware calls it network IO control in OVS. I can't remember the name of what it's called in OVS, but basically, sure, I can put a throughput limit of, say, 10 gigabits on each one of those traffic types. Okay, now I'm just artificially limiting that. What if storage replication is only consuming 3 gigabits, but I've limited VM traffic to 10 gigabits, so that way I can guarantee traffic will now VM traffic might be artificially limited. It might want 12 or 14 while the storage is only using 3.
Yeah.
So it's one of those, like,
the standard way to slow that down, by the way, with any sort of app IO control, because you could use app IO control even to limit it at the C group level. But one way or the other, the way that it does that is it introduces latency. It pauses the IO in order to get it to shape for the particular, if you say this PVC has 5,000 IOPS, if it tries to use 10,000, it introduces latency until the app eventually figures it out, because it requests something, it waits, it then does the next thing until it kind of figures it out, and you filled up the app queue at that point, and that's what's actually causing everything to be nice. So you have to do something to essentially slow down slow down the thing that you're doing wherever it is.
So yeah, to directly answer your question, though, yes, it can increase app latency. Mitigating it is choosing the balance that by you I really mean the business finds acceptable. Because the business here is, has to make that decision of, am I impacting storage latency? Am I impacting application traffic directly? Does storage latency have a broader impact and therefore more impact of the business versus per application traffic? Like, are these different? So it's one of those, as an individual, it's hard to make that decision. Instead, we go to the business decision makers and basically say, here are my trade-offs, right? Which one of these is the lesser evil? Not a great answer, but it is what it is. And I don't exactly, to your point, like, the answer is, well, bigger pipes, or dedicated adapters. That's the way that we avoid those things, and I don't know that there's another way to do that. So we're 90 minutes in. I know we've been chatting about a lot of things. For the audience, if you have any other questions, anything you want to ask, please don't hesitate to drop those into chat. We'll do our best to answer those here before we end the stream. If you have anything, if you're not watching us live, if something comes up after the stream ends, if you want to reach out, please don't hesitate. You can reach me at Sully, SULLY, at redhat.com. Johnny's not here, but I'll throw him under the bus too. Jonny, JONNY, at redhat.com. We both love to hear from the audience. We love to get your messages and all of that. So, Chris, you volunteered your email address earlier. I think it was ccrow.
ccrow at portworx.com.
So again, don't hesitate to reach out if there is anything that we can help answer with regard to that. As far as upcoming schedule, I don't know what the upcoming schedule is because I'm not here next week. So I think Jonny will be back. I don't know what's on the schedule. 2 weeks, I want to say we're going to be talking about OpenShift 4.22 and all the changes that have happened inside of there. So looking forward to that one and showcasing some of the things that are there. I've had a 4.22 cluster running for a few weeks now. There's some pretty interesting UI changes and stuff like that. Again, I'm a virtualization person these days. Who knew that 20-something years later, I'd be right back to where I started. Anyways, lots of changes that are happening in there, particularly on the networking side. There's been some changes in the various wizards that we use for configuring bare metal networking and all of that other stuff that I'm interested to get thoughts and feedback on. I know we've had the UX team on a few times, and they're always looking for feedback on that stuff as well. So Beyond that, there's just a whole laundry list of topics I still want to get to and present my storage and networking best practices sessions from Summit. I want to get them out here on the stream and get feedback from you all. I'd love to hear from you all and ask questions. If anybody will be at IBM Tech Exchange, I was recently informed that my storage session was accepted at IBM Tech Exchange, which I think is in Atlanta this year. So going back to the, Chris, I don't know if you were at Red Hat Summit, which was in Atlanta this year.
I was at the KubeCon beforehand, but
Okay.
funny story, my wife was on a knitting tour, so I was home watching the kids. Otherwise, I would have been there. In case you were wondering what everything behind me was, it's yarn.
That sounds amazing, actually.
Going in Ireland, like going to
Yeah.
breweries, and yeah, it was.
Oh, that
she
sounds
had a great
amazing.
time.
But anyways, this time, if you haven't been to the College Football Hall of Fame, like, sounds kind of like, oh yeah, college football, blah blah blah. The best part of it is they have this AI augmented college football experience. So when you
Really?
go in, like, you fill out some of your information, like what's your name and like what's your favorite food and all this other stuff. And as you go through all the exhibits, you tap a little card, and it creates these AI generated images of you in different scenarios. But it's like AI generated images from 4 or 5 years ago. So you have like 8 fingers and like all of this crazy stuff.
That's great.
There's
I
one
walked
of
by
them.
that so many times.
Yeah, there's one of them. One of our product managers, Sachin, we were going through it together, and it was like tailgating through the decades. And so he tapped his, and it scans for like the 1980s, and it's him standing next to a grill. Like, the grill is clearly cooking things, and he's leaning on it with his hand on the grill in this AI generated image. And
I
it
love
was,
it.
college football. I wouldn't say I'm not a fan, but I'm not a fan. I'm kind of indifferent towards it. But it was a lot of fun to go through and just see all the different AI generated things and the craziness of them. It was a lot of fun. Anyways, thank you very much to our audience. Thank you very, very much to you, Chris. Appreciate you coming on and knowledge dumping with us. And I've very much enjoyed our chats. So
Likewise, thank you, Andrew.
yeah. So to our audience, I will see you in 2 weeks. I will defer to Jonny about next week. If you need anything, please don't hesitate to reach out. And we will see you all soon. Uh-oh, now I got to find the right buttons. Panic, panic.